we go. Let's do this thing. So I love these chapters here at the very end. We're going to really kind of synthesize everything we've been talking about and apply it kind of to the real world, to big picture stuff. So in chapter 10, what we're starting here with is intermolecular forces. Okay, so this is what we're doing. Okay, so what we have done up to now is intramolecular forces. Okay, so let's talk about those differences. So intramolecular forces are the forces within a molecule. So that's what keeps an electron attracted to a proton, for example. It's also, when we talk about intramolecular forces, this is what the force that two nuclei exert onto each other in a chemical bond, okay? So forces within a molecule. What we're going to get into in this chapter is intermolecular forces, IMF, intermolecular forces. Those are the forces between molecules, okay? So for example, if I have two neighboring water molecules, let's say, okay, I'll draw another one up here. We know the intermolecular forces are the forces that keep all of these atoms bonded to each other. That's the intramolecular forces. The intermolecular forces are the forces exerted between two neighboring water molecules. They're the forces that keep those molecules together in a liquid or a solid, for example. Okay? So now if we look at kinetic energy of these molecules versus their intermolecular forces, or sometimes we call the interactive forces synonymous with the intermolecular forces. So this means the forces that two neighboring molecules experience, right? So if we look at like an ice cube, okay, those molecules are really close together, right, in a solid. In all solids they are. So we would say the molecules themselves have the lowest kinetic energy, but the highest interactive forces. So the molecules are glued to each other in a way, okay? In a liquid, that becomes intermediate. So in a liquid, the molecules are more free to tumble around and move. They adopt the shape of their container. And see how I can slosh this water around, right? I'm really happy I didn't spill that on my keyboard. There's intermolecular forces keeping those water molecules connected. However, because it's intermediate, I can slosh them around, right? They can move around a little bit. In a solid, I can't really like slosh a solid around, right? It maintains its crystalline structure. And of course, in a gas, these molecules are the furthest apart. Gases are not very dense, right? The molecules are really far separated. They have an enormous amount of kinetic energy. They're moving around, they're colliding with each other. And their interactive forces are therefore the lowest. So it's really all about how close neighboring molecules can get to each other. The closer they can get to each other, the stronger are their interactive forces or their intermolecular forces. Okay?